Yeah, thank you. So the James Webb Space Telescope went up, and the Big Bangers, they made some predictions, the gold standard of science being testable predictions. And you made some predictions also. So can you tell us about how those predictions, their predictions came out, and yours also?
Yeah, it's a very exciting time to be a biblical creationist because we now have access to galaxies that are farther away than anybody could have detected just a few years ago. And so in January 2022, before the James Webb had taken any data, I'm not even sure it had reached the L2 Lagrangian point yet. But in any case, I made some predictions about what I was expecting it to detect based on my understanding of biblical creation. And one of the things I predicted is that the James Webb Space Telescope will find galaxies that are at much greater distances than the Big Bang advocates were expecting. The reason for that, you see, in the Big Bang view, as you look out into space, it's kind of like you're looking back in time because allegedly the light took a long time to get here. So you're seeing things not as they are, but as they were. It turns out that depends on how you define now. It depends on what's called a synchrony convention, which we can get into or not. It's complicated. But in any case, they were expecting that at a certain distance, you're looking back to a time where galaxies didn't exist yet. And based on various models of the Big Bang and galaxy evolution, they were expecting that to be at a redshift of about 14. That should be where the earliest galaxies. Redshift it correlates to how far away something is. So a redshift of 14 is incredibly distant, and they were not expecting to find galaxies much further than that. I predicted that they would, that the galaxies would continue beyond redshift 14 further out into space. And I predicted that these galaxies would be comparable to nearby galaxies in the sense that they're fully formed, mature galaxies. The Big Bang advocates were expecting that as you look far out into space and therefore back in time, in their view, you're seeing galaxies as they were when they first came into existence. They ought to be babies, so they ought to be very low mass galaxies, clumpy, irregular, because it takes time for the stars to smooth out and form these nice spiral structures. So basically the opposite of what I predicted. And then finally, I predicted that these galaxies would have what we call metals in them. And in astronomy, a metal is anything heavier than helium. So everything on the periodic table except the first two is a metal. And in the secular view, the only metals that should exist in the earliest and farthest galaxies would be lithium. So they were expecting none of the heavy stuff, nothing like oxygen and carbon and stuff like that, these heavier elements, because the Big Bang can't produce those, even in their view. Those are supposed to be produced later by stars, the heaviest class of stars. And then when those stars explode, they release the heavier elements into the universe, which are then gobbled up by the next generation of stars. And so the generation 2 stars have some metals. Generation 1, which we would call population 3, would have no metals. So the earliest galaxies shouldn't have any. So those were my 3 predictions, and they're basically the opposite of the secular predictions. Secularists saying galaxies stop at around redshift 14, and you really can't find them beyond that because that corresponds to a time where they haven't had time to form yet, according to the simulations, according to the theory. I'm saying no, they'll continue to go out as far as James Webb can detect. Second, the Big Bang advocates were saying the very farthest galaxies ought to be babies. They ought to be low mass, clumpy, irregular galaxies. I'm saying no, they'll be mature galaxies. With structure, maybe I don't think I specifically said spiral structure, but that's what I was implying. And then third, they were saying the farthest galaxy we should finally find these population 3 stars, 0 metallicity. And I'm saying no, these farthest galaxies will have heavy elements in them, metals like nearby galaxies. And in July of 2022, James Webb sent us back the first data from these distant galaxies. And we found, lo and behold, galaxies at redshifts way beyond redshift 14, 16, 18. There's some estimates go out to a redshift of 20, which is way farther than the secularists were expecting. But I was expecting that. They found that these galaxies are far more massive than they were expecting. They did not find the baby clumpy galaxies. They found evidence of fully formed mature galaxies, even galaxies with spiral structure. They've now found evidence of barred spirals, which are not supposed to form for like 6 billion years, but there they are. So I was right about that one too. And the James Webb spectroscopy revealed that there are indeed heavy elements, things like oxygen, in these most distant galaxies. So in all cases, the creation predictions were right. The Big Bang predictions were wrong.
So Dr. Lyell, you also made some predictions about how the critics would respond.
Yeah.
Could you tell us a bit about that?
Yeah, and again, I know about rescuing devices, and so I figured I was confident enough in my predictions that they would be right, that I even decided to speculate on how secularists would respond, and I predicted that they would basically, rather than give up the Big Bang, because they're going to hold on to that tight, the alternative special creation, they don't want to believe that. So rather than saying the Big Bang's wrong, they'll just push galaxy formation back to an earlier time. And they'll say, wow, galaxies must have formed much earlier than we had previously predicted. And that is almost verbatim exactly how they responded. And I don't have the quotes in front of me, but I consulted a number of different articles, some technical papers even, that said, yep, galaxies formed much earlier, because they're finding these galaxies at distances they weren't expecting, which in their view corresponds to a much, much earlier time. And so we were right about that too. And I think that's neat, because the Bible not only tells me something about the universe, which allowed me to make these predictions, but it also tells me something about human nature, which allowed me to make the predictions about how human beings would respond. And so I think that's pretty neat. The Bible really is the best place to start.
So,
Amen.
So with this alteration of their timeline, would that affect the timeline by which they suggest that our current galaxy formed?
Oh, that's a good question. Probably not, because they think our galaxy is something like 10 billion years old. And if you want to add, if you want to push it back another few hundred years, I don't think a few 100 million years, I don't think that's going to affect our galaxy too much. But it does affect it shows that the simulations were wrong, because the simulations showed that these galaxies take longer to form than that, and would take much longer to become spirals. So it challenges galaxy formation models very severely.
What do you think this information should have meant for the people who believed in the Big Bang?
I would hope that it would give them pause, that they would step back and say, wait a minute, is our underlying worldview possibly wrong? I mean, we've got a creationist. We've been saying that, science is all about making good predictions, and it is. The creationists are making the right predictions. Our predictions were wrong. Maybe we need to rethink things here a little bit. Maybe we ought to consider biblical creation. And don't get me wrong, I'm not suggesting that they should believe in the Bible because of this new evidence. They should believe in the Bible because it's God's word. Right. But I would hope that people who have not been believing the Bible because it's God's word would consider starting. I think that this evidence is very compelling. It's consistent with creation, and it does challenge the standard paradigm. And the other thing that's interesting too, I have seen some secularists publish in secular peer-reviewed literature, technical literature, some models that are contrary to the Big Bang. They're not creation models, but based on these new lines of evidence, they're challenged. That the tired light model is coming back a little bit. I don't think that'll catch on, but I think it's interesting. That was a model that was abandoned almost a century ago, and now it's back because the data do not match the predictions of the Big Bang. So I think that's exciting. So at the very least, I hope it'll get people to question, maybe we need to reconsider our underlying paradigm rather than simply slapping band-aids on this model, coming up with rescuing devices to explain away the data.
Right.
If I can ask one more type of follow-up. So the Big Bang model, it has changed throughout time. When I was young, it was explained much differently. So it's currently explained as if you were to take a partially blown up balloon, put dots on it, and blow the balloon up. They'll suggest that almost like it has like a sphere that's expanding. Is that part more philosophical than it is scientific? Or do you think that they actually have scientific justification for suggesting that the shape of it is more of a sphere, which would mean, it seems like that would mean that there would be many more dimensions, because you would have internal dimensions in there, at least 3, and then an external dimensions, which would be 3 more. So you're at least 9 dimensions. And if there's a barrier outside, what does all of that mean?
Okay, that's tricky.
Okay.
So the idea that the fabric of space expands like a balloon, I would call that a scientific hypothesis because it's testable. And in fact, it's been challenged recently by me. I published a new model that challenges that idea, because I always accepted that. Not that I believed in the Big Bang, but I thought the fabric of space expands and it carries the galaxies along with it. Does that imply extra dimensions? Not necessarily. And the reason why we tend to think in terms of Euclidean geometry, where the internal angles of a triangle add up to 180 degrees, and it's nice. And that's the geometry that we learn in high school. It's not the only geometry that's out there. But it turns out there are other geometries that allow for an expansion of the universe that don't require any dimensions outside of it. I know that's a little hard to grasp, because when we think, well, if you think of the surface of a balloon as a basically two-dimensional structure that's expanding in a three-dimensional space, that's a mental way of picturing the expansion. It may or may not be accurate, but you'd say, well, doesn't that require a larger dimension? Not necessarily. You could have a balloon that's two-dimensional that expands only in two dimensions, but does not obey Euclidean geometry. I don't know if that makes sense or not. The embedding is where we pretend there's an extra dimension, and that keeps the geometry Euclidean. But you don't actually have to do it that way. Mathematically, it's not required. So we don't need extra dimensions. That doesn't deny that there could be extra dimensions. It's just we don't need them to account for the expansion. The idea that the fabric of space expands like a balloon is allowed by Einstein's general relativity. It's not required, but it's allowed. And under certain assumptions, you would expect that to happen. And so that was realized in the 1920s. There were 4 scientists that independently realized that Einstein's solutions allow for the fabric of space to be expanding or contracting. And then when Edwin Hubble discovered and published in 1929 his Hubble, what we now call the Hubble law, that galaxies are all apparently moving away from us and from each other, some exceptions that are really nearby. But there's a general trend that the universe seems to be getting bigger. People thought, aha, that means the fabric of space is expanding and the galaxies are just going along for the ride. But it turns out that makes certain testable predictions about the relationship of a galaxy's apparent size, how big it looks, and its actual distance away from us, which we calculate by its redshift. And it turns out that if the fabric of space is expanding, there's actually a magnification effect that kicks in. You know how things, when they're farther away, they look smaller. That's perspective. Their angular size shrinks. Now, in an expanding universe, that effect is there, but beyond a certain distance, there's another effect that overcompensates for it and makes them look bigger again. And so if the fabric of space is expanding, galaxies beyond a redshift of 1.6, rather than looking smaller as they get further away, they should start to look bigger again due to this magnification effect. I won't go into the math of why that happens. It just happens. And secular and creation physicists, we would agree that that happens if the universe is expanding. But what I realized when I looked at these James Webb galaxies, I mean, we're looking at tremendous, they ought to look huge. They ought to be much bigger than they are. And the secular assumption is, well, they're really tiny for some reason. But we already know they're massive. Their mass is similar to nearby galaxies. And so what I did was I computed what would their apparent size be if the fabric of space is not expanding, but in fact, galaxies are just moving through space. And it turns out it matches almost exactly the sizes of these galaxies as we're seeing them. And so I'm calling this the Doppler model. It absolutely is devastating to the Big Bang, because you can't have a Big Bang unless the fabric of space goes back to a point at one point. And that apparently is not happening. The fabric of space is more or less stationary, and galaxies are just moving through it, such that the farther away they are, the faster they're moving. And so, but their redshifts are caused by a simple Doppler effect. And so apparently the correct picture is not dots on an expanding balloon, but pool balls on a pool table after you crack the deck. The ones that are moving away the farthest are the fastest, but the table's not expanding. So that's called the Doppler model, and I've recently published an article on that in the Answers Research Journal. So I hope that wasn't too technical, but hopefully.
No, that was good. And I think your last illustration there made a lot of sense of it. And so firstly, I've posted your recent technical paper in the Answers Research Journal in the chat for people to read. And so essentially it comes down to the picture that we see may be better explained by this Doppler shift rather than expanding space, which has been the prevalent view for years and years.
Yep.